Imagine a lake covered in a dense green mat of plant material. Boats traveling by get their engines filled with plants, and native fish and wildlife rarely see the light. Hi, my name is Rachel Lee, and I want to introduce you to Salvinia. Salvinia are invasive aquatic ferns native to Brazil, but have since become noxious pests in many regions worldwide. Locals, such as this man here in Cattle Lake, Texas, have tried to get rid of this pesky weed by introducing even more foreign organisms to the environment, which could possibly throw the ecosystem more into chaos. Now, what if there was a way that we could get rid of these plants and also help the environment at the same time? Salvinia float very well on the surface of lakes, which led to the realization that they are super hydrophobic. Hydrophobic means water hating. The high contact angle between the water droplet and the Salvinia minima frond shows that the top surface of the leaf repels water extremely well, causing the water to bead on the surface. However, substances that repel water often attract oil as well, since water and oil are polar opposites. And so, using two species of Salvinia, S. cucullata and S. minima shown here, I want to test how the trichomes, tiny hair-like structures, would affect how well the fronds would absorb different viscosities of motor oil. I would take a frond from the cluster, dip it into a lower or higher viscosity motor oil, and then record the mass change. Here, in this video, you can see a demonstration of the sorption process. The frond rapidly sorbs the oil in less than 13 seconds, and no visible oil remains. Running a one-way ANOVA followed by a post-hoc Chaffee test with p-values less than 0.05, S. cucullata was significantly more efficient at sorbing low viscosity than S. minima, while S. minima was significantly better at sorbing high viscosity oil than S. cucullata. But to understand why this was the case, we should look at the trichomes. Both S. cucullata and S. minima have bent trichomes that allow them to bend to the shape of an oil droplet and provide a greater surface area for the oil interface to adhere to. However, if the surface tension of the oil is too low, the tip breaks out of the oil interface and the available volume for retaining oil is decreased. S. cucullata is very flexible, while S. minima is very stiff. So, S. cucullata can bend well for low viscosity oils to adhere to, but bends too much in high viscosity oil. Meanwhile, S. minima is stiff and the tip breaks out in low viscosity oil, but breaks out less in the higher viscosity oil. It is a combination of these trichomes and hydrophobicity that allows Salvinia to be such excellent oil sorbents, with over 200% mass change for all groups. By utilizing Salvinia as biodegradable oil sorbents, we would be able to help decrease the Salvinia populations in places like Cattle Lake, while also keeping our oceans clean. Hopefully, research in this field will contribute to finding an efficient and biodegradable tool to clean up oceans. Thank you very much for listening.